Hello. I want to welcome everyone to today's webinar on behalf of Viavi Solutions and IMA Active. My name is Claude Robotham, and I'm a product line manager at Viavi. Viavi Solutions is an industry-leading network testing and optical coatings company based in the U.S. Today's webinar is one example of how Viavi is leveraging its innovative linear variable filters to deliver high-performance, robust, and small form factor process monitoring solutions. Today, we'll introduce you to one of our MicroNIR Process Analytical Technology instruments and provide a live demonstration of real-time blend uniformity monitoring. Our MicroNIR PAT product line is designed and optimized for inline process monitoring applications for pharmaceutical, chemical, food, feed, ag, and other industrial applications. And now I'd like to introduce you to our host for today's webinar. Jussi is a senior technologist for granulation and mixing equipment at IMA Active, and Emiliano is an account manager for Viavi Solutions, covering EMEA and Latin America regions. Thank you for attending, and I hope you enjoyed today's webinar.
Thank you, Claude, for this nice introduction, and welcome to everybody to this webinar. We are here in one of our process room in EMA, and I am together with Emiliano, which I personally want to thank for this great collaboration we have since a lot of years. Thank you, Emiliano.
Thank you, Jussi, and I would like to welcome all the attendees to the webinar. I'm very glad to be here and follow together the blending monitor application by NIR. I also want to thank EMA for the hospitality and for all the effort that we are doing together on the PAT applications.
Our main goal today is to show you a useful method to monitor and verify the blend uniformity on a binary mixture of powdered components. Before to go deeply in the practice, I need to absolutely start talking about the process analytical technology approach that differs from the traditional approach to keep the process as constant as possible, minimizing the changes in selection of powder material suppliers, process parameters, and method of analysis. In a lot of cases, can happen that the blend is not so homogeneous as desired, and also the final properties of the blend are not in the specification. This, of course, can increase the time for both process and formulation development. One of the main advantages in having a NIR sensor installed on a blender is the possibility to determine in real time the raw material critical quality attributes. I'm right, Emiliano?
Yes, Jussi, sure, you are right, and not only, because the traditional way to control a blending is prescribed by the ICH guideline. In this document, it's clearly written that you need to take 10 samples with a sample teeth and bring it back to the laboratory where you will perform a UV visible or an HPLC measurement. This is clearly not an online approach because the analysis has to be done only once the blender is stopped. Clearly there are three disadvantages. First of all, that as I just said, you need to perform the analysis offline and bring the sample to the laboratory. The second point is that it's time consuming and is also quite expensive because for every sample you need to come to the laboratory and do an HPLC analysis. The third point, that is probably the most important one, is that when you go inside with a sample teeth, you are creating a hole, and this hole is immediately filled by the finer particle size. The consequence of this effect is that you are completely destroy your blending just to make the analysis. If you are interested in having more information regarding this effect, I really suggest you to read the article on paradigm shift of sampling theory from Professor Romanak.
Let's now get to the equipment. Cyclops is a bean tumbler designed for blending and homogenizing powders and granules for pharmaceutical, food and chemical industries. The industrial size machine can be installed through the wall for top-level GMP configuration and space saving in the processing area, while the lab version, used for small batches and laboratory applications, is wheeled for an easy moving inside the process room. The bean container geometry is proportional to the industrial bean, ensuring a good scaling up. The main critical process parameters that are taken into account to get an optimal blend uniformity are basically three: bean filling, from 30% up to 70% of the total bean capacity; mixer speed, from 10 RPM to 20 RPM; mixing time, from few minutes up to 30 minutes. The lid of the bean can be fitted with a dedicated flange on which the sapphire window is sealed. The 3 clamps connection is the easiest way to connect the sensor on the lid, while, once dismounted, room contamination is avoided. In this way, it is possible to use the same lid even if the NIR monitoring is not required. This strategic position on the lid allows high accuracy during the process monitoring, since the dead zones that can affect the reading are eliminated.
Viavi has developed an NIR product line based on the linear variable filter. The main advantage of the linear variable filter technology is that there are no moving parts inside the devices. Therefore, the 2 immediate consequences is that we can produce a very miniaturized NIR sensor like the PAT-W that I have in my hands here, and that is dedicated to static application, and also that the devices are completely maintenance free, just because there is nothing inside that is moving. It is interesting now to see how we can apply a MicroNIR to a Tumble blender. In particular, in this case, we are using a PAT-WX, that is the hazard lock certified version of the classical PAT-W. The PAT-WX is, as I said, similar to the PAT-W, a completely wireless device. In particular, it has a battery that has a working time around 8 hours and also 2 antennas in order to enable the wireless communication with the computer. On top, the device has a gravity sensor that we will see in a while how can be set, and also it has an embedded computer that is very important in case of Wi-Fi outage to keep the data stored in the proper way and therefore for data integrity. As I just said, the PAT-W has an integrated gravity sensor that enables the trigger only when the product is in contact with the windows. This setting can be defined easily looking at the blinking light. Before scanning your production, we need to make sure that the light is blinking in an angle where we have the product in contact with the windows itself. MicroNIR has a trigger that starts at 9:15, but increasing properly the delay time, we can make sure that the acquisition is starting in the proper angle. The trigger setting, they depend from the bean geometry and also from the rotation speed. Setting properly the trigger is a key point to achieve good spectra. The philosophy behind the application of the NIR spectroscopy to the bean blender is to use the NIR spectrum as a sort of fingerprint. In this specific case, we are mixing 2 ingredients, lactose and talc. Before adding the ingredient to the bean, we have recorded the NIR spectra. The gravity sensor embedded in the PAT-W and WX allow to acquire a spectrum every rotation. In the beginning, the spectra will be for sure different, and afterward they will become more and more constant. A very simple algorithm that allows to monitor in the proper way the spectral variation is the so-called moving block standard deviation. As you can see from the plot, for each rotation we calculate the area. A standard deviation is calculated on a block of 5 or 10 spectra. In the beginning, the standard deviation will be high, and afterward it will decrease, tending to 0 when the blending is gonna be uniform. The moving block standard deviation is often preferred to the principal component analysis because it's a very simple algorithm and is able to get the result from the first batch without the need of creating a calibration. The moving block is a very simple algorithm to explain to an auditor, and it doesn't require a lot of statistical knowledge. We can also make a quantitative analysis, but the downside in this case is that it's pretty time consuming. From the blending profile, we can extract very important information. Looking at the number of rotations, where the standard deviation is minimum, you can define the endpoint. Looking at the 8 you reached, you can see if a process is producing a better result than another one.
There are two main reasons to install a NIR sensor on a blender. If you are operating in a formulation lab, you have the possibility to monitor your process in case you change a component in the formula, having, for instance, different particle size or flowability. The main advantages having this technology is to have results in real time without the needing to calibrate the sensor. While if you are operating in a production area, with this technology you have the possibility to skip easily from a process validation to a continuous process verification. This is why NIR is considered to be a very powerful tool to keep under control your process and improve the process development. Last but not least, I turn to Emiliano to conclude with a very interesting application.
Thank you, Giusy. I'm very glad to introduce the new functionality of the MicroNIR Pro Software 3.2 called Golden Batch. The Golden Batch is nothing else the average of the different blending profile in order to be able to understand if the blending process are coherent each other. In the graph, the golden batch is displayed with a yellow line. The minimum is a dashed blue line. The maximum is a dashed red line. In this way, you can keep under control your process in a very simple way. You just need to look at where your profile is laying down. If there is an overlapping with the golden batch, is fine. Or if you see that you are going out one of the two dashed borders, mean that there is a red flag that needs to be investigated in the laboratory.
Thank you very much for your attention, and visit our website at the section dedicated to the case studies and applications.
Thank you, Giusy, and thank you, Hima, again for the invitation. Feel free to contact us for any information you need.